Okay, good morning. I will wait a little bit for you so that everyone can join. Okay, hopefully now we can start the lesson. So if you remember what we learned about trigonometry in the previous session was more or less everything was a repetition from the previous courses. But now this is a new topic and it is extremely important. So trigonometry, if you want to follow your education somehow related to mathematics, so trigonometry is always with you. And usually my experience is that because there are many things to remember, you need to practice a lot to be very fast and quick in trigonometry. Students are a little bit weak in trigonometry, but I just want to warn you that this is an extremely important lesson, so you need to learn it very good, okay? It's simple, the ideas are very, very simple, but you need to get used to this way of thinking, okay? So, of course, we will start trigonometry in the unit circle in a limited version, and then the complete version of it will come in Math 4. So the first thing that we will study in Math 4 will be trigonometry, okay? It's a very long chapter there. Okay, so trigonometry in the unit circle. First of all, let me tell you what do we mean by unit circle, by the unit circle in mathematics. So this is a very well-known word. So it means that if you have a coordinate system, let me make it a little bit nicer. If we have a coordinate system here, say for example, this is the y-axis and this is the x-axis. Okay. The unit circle, it's clear from the name, its radius is one length unit, yes? And then the center is the origin. So this is, you need to know, when we talk about the unit circle, we mean a circle, the center is at the origin. So let me see if I can draw it a nicer picture using this protractor. So here, when I talk about the unit circle, I mean something like this. Change it the other direction. Okay, so yeah, the center is at the origin and the radius is 1 unit. This is in the definition of the unit circle. So let me write R for the radius. It is 1 length unit. And the center is the origin. So it means that if I ask you what number is here, you would say this number is equal to 1 because the length is 1. And if I ask you what is the x-coordinate of this point, you would say -1. What is the y-coordinate of this point? The +1. What is the y-coordinate of this point? -1. So this is the meaning of having a unit circle. So in trigonometry, for this unit circle, we consider an origin and a direction, yes? The origin of this unit circle is this point, the point of intersection between the x-axis and the unit circle, okay? So let me change my color. So let me call this point A. If someone asks you what is A, I would say this is by definition the origin of this unit circle. And if I go counterclockwise, this is by convention the positive direction. Clockwise direction is considered to be the negative direction. So here, by convention, this direction is considered to be positive, and this direction is considered to be negative. Okay, So there is a many, I want to talk first about trigonometric angles. So in geometry, the angles, the lowest possible value for the measure of an angle is 0 degrees and the highest value is 360 degrees, yes? But in trigonometry, we can have any angle that you like. We can have, for example, an angle of the size 400 degrees. And we can have an angle of size minus 30 degrees. Okay, so this is the main difference between a trigonometric angle and a geometric angle. So a trigonometric angle can be even negative, it can be even greater than 360 degrees. But when we talk in geometry, we don't have that situation. Okay, so but how we want to make sense out of it? This is important to understand. How should I visualize the angles in this unit circle? For example, when I say you 30 degrees, positive 30 degrees, what does it mean? This is the convention. One leg, an angle, for example, has two sides, yes? Always and always you choose one side to be on OA. This is by convention. And then you will start rotating about the origin in the appropriate direction, which is designated by this sign, positive or negative, and according to this value. So when I want to represent this angle on this unit circle, I will start from OA. I will start rotating in positive direction because that is positive 30. And then I will rotate exactly according to that angle, 30 degrees. So I will rotate until I reach, for example, reach to this point. Assume that this is 30 degrees. Then I stop. So if I ask you to represent this angle on the unit circle, this is its representation. And then what is important, the starting point is always this A, the origin of the unit circle. What is crucial in your understanding in this new lesson is the final point. What matters for us, you will see why. What matters for us is the final point of angles. In trigonometry, the sizes are not, of course, sizes are also important because it will affect the location of this final point. But what matters at the end is this final point. If I have two angles with different sizes, but with the same final point, then you will see that if you want to calculate sine, cosine of or tangent of those two angles, even though they have different sizes, they give rise to the same number. Okay, this is what I want to talk about this today. Okay, so now assume that I ask you to locate the final point. This is extremely important, very simple, but very important. Assume that I ask you to locate the final point or represent this angle minus 60 degrees there in the unit circle. So what does it mean? It means that again, you will start on this OA. This is the one side of your angle. And then you have to rotate 60 degrees about the origin. But in which direction? Because the sign is negative, I have to rotate it in the negative direction. So I will come here, I rotate 60 degrees, more or less. If you want to visualize it somehow, I will end up somewhere here. So let me give this a name. For 30 degrees, I ended at M. For minus 60 degrees, I end here. And if I ask you how much is the angle, you see, if I ask you what is the size of the angle, the measure, it's of course 60 degrees. But this angle is minus 60 degrees. Okay, and you know that if you have any questions, you can communicate with me through the Zoom. Okay, so this is the final point which corresponds to minus 60 degrees. Okay, let us consider, for example, 300 degrees. Where 300 degrees is. Okay, so for example, let me change my color. You start from here. You are supposed to rotate about the origin 300 degrees. There is no sign behind that. It should be in the positive direction. So I start from here and I move 300 degrees. Can you guess where I will end? after doing that? Three hundred degrees. I start from here and I will rotate 300 degrees. You know that the full circle is 360 degrees. So, and the measure of this part is 60 degrees. So hopefully it will be clear for you. If I start from here, when I rotate up to here, it is 90 degrees. If I continue rotating up to here, it is 180 degrees. If I continue a little bit more, it becomes 270 degrees. And I need to go 30 degrees more. I hope that you agree with me. This is 30 degrees. So it means that you will end up to the same point. Let me just draw something here. Exactly on top of this blue dotted line. And then let me call it P. So if I ask you where is the end point corresponding to this angle, you would say that as far as the end point is concerned, it doesn't matter if I go minus 60 degrees and 300 degrees. They are, of course, different angles. This is negative, this is positive. The size of this one is smaller than the size of that one. But what matters in the future is the final location of the point corresponding to those angles. Hopefully you agree with me, both of them will be on the same sign, on the same point. Later, we will see that if you calculate sine of this negative angle, for example, it becomes exactly to the sine, equal to the sine of this angle. So the angles are quite different, but what matters is the final point. I will discuss about that. But I just want to make sure that you really understand what is the meaning of these angles. So for example, I want you to understand that if I ask you which angle corresponds to this final point, one possible answer is 0 degrees. But this is not the only answer. There are infinitely many answers for this point. For example, you can say 360 degrees. They are quite different, but if I start from here and don't rotate at all, the final point would be A. If I start from here but rotate 360 degrees, of course I am moving around, but the problem is that I will end exactly at the same point A. If I ask you, give me another name for the same point corresponding to the same point, you can also mention minus 360 degrees. Yes, because this time I start on A as usual. I rotate 360 degrees, but in the negative direction. But if I go one full round and go back, I will end up at the same point. By the way, why we should stop here? I can give you another name, 720 degrees. This is a strange, yes, because this is bigger than 360 degrees. But what does it mean? It means that I start from here and I will rotate 720 degrees about the origin in the positive direction. So if I start from here, I go one full round, it is up to here, it is 360 degrees yet. So it means that I need to continue to traverse this circle. So if I go more and more, so I will get another 360 degrees and I will end there. So you see, when I talk about 720 degrees, it is also imaginable. So the angles greater than 360 degrees are imaginable in this way, okay? So, but the point is that if you want to point to this final point, you have infinitely many names, okay? You have infinitely many angles. All of them correspond to the same point, okay? What matters at the end, somehow we will see that whatever this angle can do for us, this angle also can do for us, this angle can also do for us. So this is important to understand. For example, can you give me another name for this? I don't know, are you willing to answer or not? Yes. So how can you give me another name for this final, corresponding to the final point M? Yes, anyone? 390 degrees, thank you. So you start from here, you go one full round, it becomes 360. You go a little bit more, it becomes 390. So you see, for this point M, I can call it 30. I can even call it 390 degrees. Not this doesn't mean these angles are equal, no, but they correspond to the same final point on the unit circle. Yes? Can I give a negative name for M? What can I do? I go the other way around. For example, I reach here. So how much is that? It is 330 degrees, but in the opposite direction. So I can give it minus 330 degrees. So this angle, this angle, this angle, they are different angles, but they end up exactly at the same point. Yes? So can you cook up a recipe? Okay, so can you tell me, if I give you an angle theta, can you give me a formula which generates all angles that corresponds to the final point as the final point of theta? Is the question clear? So I give you an angle. Let us consider, for example, 30 degrees. Can you list below, can you list here all possible angles, so that even though they are not equal to this, but the final point of those angles corresponds, lies on the same final point as this angle? I want to generate all of them in a compact formula. Can you do that for me? Anyone? Because if you want to, for example, this is M, the final point of 30. If I want to end at the same point, can I move a little bit? No, I need to go one full round. Yes? I need to go one full round and go back to the same point. And this full round doesn't matter. Is it one full round or two full rounds or three full rounds, and etc. Okay? But if I don't go a full round, it is not possible to come back to the same point. Yes? If I go a little bit even smaller than 360 degrees, I will not end exactly at the same point. So it is clear that the angle 30 is at this point. 30 plus 360. This is also definitely here. This angle is 390 degrees, but it ends exactly at this point. What is the other one? Plus 2 times 360 degrees. What is the other one? 30 plus 3 times 360 degrees. And hopefully you agree that this list can continue similarly, yes? But here I added 360 degrees, but equivalently I can subtract. Instead of going one full round in the positive direction, it doesn't matter, I can go one full round in the negative direction. I will end up again at the same point. So another list that I can write is 30 minus 360 degrees. What is this number? This number is 390. What is this number? 2 times 360 is 720. So this is nothing except 750. This is, I don't know, nothing except 1000. Yeah, I think so, yes. 3 times that is 1000. No, 10. Yeah, I don't know, but I mean, you can calculate these numbers yourself, yes? But anyway, I can also consider this scenario. I can consider this scenario with 2 full rounds, but in the opposite direction. I can consider this scenario with 3 full rounds, but in the opposite direction. Okay? So you see that this I want you to learn. This is crucial to understand. So you see, if I ask you find the final point of 30, then there is one single point. But if I reverse the question and I ask you find the angles whose endpoint are at M, there are infinitely many. One of them is 30. But there are infinitely many names. It is extremely important to see the question. If I give you the angle, if I give you a fixed angle, there is only one single point that corresponds to that fixed angle. But let us give you the fixed point, and I ask you how many angles correspond to this point. You should say infinitely many. One of them is easy to find. You connect that point to the origin, take your protractor, and measure this angle. This is usually called the main angle, okay? But the main angle is just only one among infinitely many possible answers. But the point is that I can list all of them like this. But instead of writing so much, we want to compact it into one nice single formula. Can you tell me what the formula is? If I ask you, give me all the names, not the names. If I ask you, give me all the angles which will end up at the final point of 30, you see all of them in this list. But can you cook up a formula for that? So, yes, may you repeat it, please? 30 plus?
30 plus minus 366.
What do you mean by x then?
Amount of rounds.
No, what is x? You need to, you are more or less you are on the correct track, but you need to say what x is.
How many times you go around?
Yes, exactly. So that's an integer. So that is an integer. Okay, so instead of writing plus and minus, let me write it this trick. This is the trick that people use. They write 30 degrees plus n, because usually in mathematics, when we want to give a symbol for discrete numbers, integers, we use n, not x. But that is not mandatory, but let us respect the rules. So I will write n multiplied by 360 degrees. Instead of writing plus and minus, I always write plus, but I say in front of that, n belongs to z. If you don't like this symbol, you need to write n is an integer. So this symbol means n is an integer. I prefer to that. The one that Dylan mentioned, you can write it in this way. You can write it as 30 degrees plus or minus n times 360 degrees. But then, in that case, if I ask you how many formulas you have, you would say I have two formulas, one for plus, one for minus. And then you can write n belongs to n. Natural numbers, yes? Including zero. You see, natural numbers including zero. So you see, technically, I have to write a lot. First of all, I have to write plus and minus, because now I am taking n only in the set of natural numbers, so they are positive, but I am taking care of positiveness and negativeness by this alternating sign here. But why should I make trouble for myself? It's even more compact. But you were right, Dylan, you were on the right track. I would prefer this one. I want you to understand, when I write something like this, what do I mean? So all the angles that end up at this point can be formulated using that single formula. 30 degrees plus n is a whole number, times one full round. If this whole number is a positive number, I am actually rotating about in positive direction. But if this whole number is a negative number, I am going full rounds, but in the negative direction. So I want you to understand what is the meaning of this. So this becomes 30 degrees plus n times this, and it is crucial to write n belongs to z. So if someone asks you what I have written here in this box, you would say this is the whole possible angles. This formula will generate infinitely many angles, not one, even though I have written it in one form. If someone asks you how many angles are included, you would say infinitely many, one for each choice of n. But because in z there are infinitely many numbers, it means that for each one of them I get an angle, so it means that I have infinitely many angles as we have desired. So you see, it's this kind of combination. This kind of combination is ubiquitous in trigonometry. I don't know, an angle plus a multiple of 360 degrees. I don't know, an angle plus a multiple of 180 degrees. These kind of things. Usually, if you look at the faucet in the back of the book for some trigonometry problems, you will find the faucet written it in this way. So I want to get used to it. So that's not something mysterious. So in general, if instead of 30, I give you just angle theta, for example, and if I ask you what are all the angles that corresponds to the same final point as the final point of theta, then it becomes clear. You just write theta plus n times 360 degrees, and then n belongs to z. So extremely important to understand. Okay, so consider this one that I have written here. 30 degrees plus n times 180 degrees. Let me review these questions. What is the meaning of this formula? How should you interpret this formula? This formula gives you infinitely many angles, not one angle, even though you have written one single formula, but it generates infinitely many angles. So can you write the angles which are generated by this? We will see. How should I generate? For example, I choose n equal to 0. Is it acceptable? Yes. Can I choose n equal to 1.5? No. 1.5 is not an integer. So I have to choose only integer values of n. Let us choose the simplest possible case, 0. If I plug this 0 here, what will happen? It generates 30 degrees. Okay, put n equal to 0. So one possible answer here is 30 degrees. Another possible answer is choose the next number, n equals to 1. So what happens? It becomes 30 plus 1 times 180. So it becomes 210. Yes? I choose another one, the next number 2, so it becomes 30 plus 2 times 180. If you calculate this, it becomes 390 degrees. So you realize what is the meaning of this formula. When we write it in one single compact form, we mean all possible angles that you generate here, but you also need to consider negative values. This is extremely important. So you need to consider -1. If I put -1 here, so let me write a line. So this is positive, n equals to 0, 1, 2, etc. Let me now consider, for example, -1, -2, etc. So if I put -1, it becomes 30 degrees minus 180 degrees. It becomes minus 150 degrees. And if I put, for example, -2, it becomes this minus 2 times 180 degrees. So it becomes minus 330 degrees, and this list also continues. So you see, this compact form generates infinitely many angles. If I ask you, if I insist to find them or to find some of them, you can actually find that. Yes, you can just give numbers to n and calculate the numbers. But if I really want to understand the final points, this is important. Of course, this is something very easy, but let me ask you, can you tell me, if I consider all possible angles you see here, how many final points I will get? You see, if I ask you this question for here, how many final points I get here? I get only one final point, and that is the point corresponding to 30 itself. But if I write a formula like that, do you think it will correspond to one single point or more points on the unit circle? And can I categorize them, classify them?
Is it 2 points?
There are 2 points, yes? Which one point is m? Because you see that I am not going one full round. 180 is not one full round, it's one half a circle. So I am adding multiples of half a circle. So if I start here, I am not going one full round. I go just 180 degrees. So where do I end? I end exactly at the opposite point. So you see, this is one point, and this is another point. Let me call it n. Okay, so do you agree? I started from here. If I rotate 100 degrees in the positive direction, I end up here. But I have to continue. When I put n equal to 2, it means that I go 2 half circles. 2 half circles means one full round. So it means that if I start here, I go here, this will generate one angle for me, but then I have to go back, I will return to the same point, and this process will repeat itself. So I will not be able to get any extra points out of this formula. If I ask you how many angles are involved, you still say infinitely many angles, but all those infinitely angles fall into 2 groups. If you choose an odd number, if you choose an odd number for n, you end up here. If you choose an even number for n, you end up here. No other points. Yes, this is important to understand. This formula generates 2 points only on the unit circle. Yes? For example, let me consider this scenario. What do you think about this scenario? Let me write this formula for you. I would start with 30 again. By the way, I have chosen to start with 30, but that's nothing particular about 30. So let me consider this scenario. Plus n times 90 degrees. So how many points on the unit circle are there?
4 points.
Yeah, this becomes 4 points. Do you agree? Let me clean this one to understand them one by one. So if I give 0, by the way, I am a little bit careless. Don't be lazy, especially in the exam. You have to mention what is the meaning of n. N is an integer. So if I put 0, I end up exactly at 30. But if I put n equal to 1, 90 is a quarter of a full round. So it means that the first number will rotate this here. It gives me this point. So let me call it M1. So let me call this one M1. This was the first point, and this will give me M2. And then if I give 2 to this one, what happens? It becomes 2 times 90, which is 180, half a circle. So I start from here, go half a circle there. So at each step, I go a quarter of a full circle. So let us do it in this way. So the first thing, I rotated 1/4 of the circle. When I put n equal to 2, I will rotate 2/4 of the complete circle. So I will actually end up here. This is M3. And if I give you one more, I will end up here. This is M4. And if I do it once more, I will end up the same point, and the process will repeat. So you see, if I give you this formula, geometrically, you need to have this visualization. You need to understand that this single formula, how many angles are there in this formula? Infinitely many. But they fall into 4 classes. This point, this point, this point, and that point. Nothing else. Okay? So is that understandable for everyone? Good. So this is something that I wanted to discuss about. Let me ask you a little bit different question. These are, by the way, these are really, really important when it comes to the trigonometry of the unit circle. So let me clean this and now ask you this question. Let me ask you this question. Can you write, of course you had it already on the board. Can you give me a formula that generates only these 2 points? M1 and M2. Okay, we already had the solution. Can you write a formula that generates this? What is the formula generating only these 2 points? So it is clear one of them is 30. Am I allowed to write n times 360? If you write this formula, it generates one of them. Yes? Because when you, for example, when you put n equal to 0, it becomes 30 degrees. That's okay. But when you choose n equal to 1, be careful. You are not allowed to give n equal to 1/2 because n should be an integer. So if you put 0, you get 30. The next step is not 1/2. Is not 1.5. It is 1. And after 1, it is 2. So this formula is capable of only generating these points. Because if you start choosing different values for n from the set of integers, you have just jumping one full round in this direction. So you are ignoring this point. So if you want to write a formula that generates only these 2 points, only exactly these 2 points, then it is clear that this shouldn't be 360 degrees. This should be 180 degrees. Okay? Now, if I ask you, for example, can you give me a formula that generates these 2 red points? Let me write these red points here. So give me a formula. So this angle is 90 degrees. And this angle is opposite to that. So let me call it N1 and let me call it N2. Now, can you give me a formula that generates only N1 and N2? Not the whole 4 points, only the red ones. What is the formula?
90 plus n times 90.
No, not 90. Be careful. Be careful. So what Dylan said is that 90 plus what you said, n times 180. This is not correct. Is there someone to correct this? 120, thank you. Because I told you, even though I wrote it here for your guidance what that angle is, but always and always measure the angles. One leg of the angle is always OA. I told you in the beginning. So if I ask you, if this is 90, if I ask you, give me an angle which end up here, you shouldn't say 90. You need to measure the whole angle from line OA, and that would be 120. So you need to write 120 here. Yeah, please let me know if you don't understand so that I can repeat. 90 is wrong. Okay, so this of course, I'm a little bit lazy because every time that I am using n, I mean an integer, but you have to emphasize it in your exam. So this blue formula only generates these 2 blue points only, but there are infinitely many angles. This black formula generates the red ones only. Okay? Is that understandable? Okay. Now let us consider this scenario. What this formula will generate, do you think? 180 plus n times 180. Where are these points? Where are these points?
Parallel to the x-axis.
So exactly, can you tell me where? Yes, more or less you mean. Do you really mean this point or not? This point? Yes?
Yeah, that point
And A, exactly. Thank you. That point and A. Because it's clear, when I put n equal to 0, I get 180, which is here. If I put the next n equal to 1, 180 is 360, so that's here. So this point will generate these two. One thing that I want you to understand is this. You might solve a problem and you get this answer. Later we will see. We can solve equations and things like that. You get this answer. But when you go back to look at your answer, to check your answer against the faucet, you see that the faucet has written this. So what I'm saying is that, for example, in the future, we will learn how to solve equations, trigonometric equations. You learn, you solve it, and then you find this as your answer. And then because you want to make sure that you have done it right, you go to the back of the book to check your answer against the faucet. You surprisingly see that the answer in the faucet is this one. Okay? Now, I want you to understand, we want to talk about this. This is an extremely important idea. I want you to learn it. Do you think that this is wrong, that is right, or that's a typo here, this is right, that is wrong? I want to understand, I want to listen from you, hear from you, okay? I want to listen what you are saying about this. Which one is correct and which one is wrong?
They're both correct.
They are both correct. Thank you. Thank you. So this means that this is important. If you find this answer and you see that the faucet has written that answer, you need to understand yourself that they are equivalent. Because in trigonometry, in this topic, the explicit form doesn't matter. What matters is that which points is this formula generating on the unit circle and which points this formula is generating on the unit circle. If you convince yourself, if you can convince yourself that they generate the same set of points on the unit circle, exactly the same set of points, then these two formulas are equivalent. This is easier to understand it geometrically, but I want you to understand it algebraically. I will talk about that a little bit later. But let us check that what this formula generates, the same formula also generates, and the other way around. If I ask you, what are the 4 points generated by this formula, you start at 180, but each time you are allowed to go half a circle, to rotate half a circle, either positively or negatively. So if you start from here, rotate positively 180, you end up here. Rotate positively 180 more, you end up again here. So this process will repeat itself. So you will only get 2 final points, nothing more. Yes? And it doesn't matter if you go in positive direction or negative direction. It's not possible to get out of it, so more points than these two. But let us momentarily forget about this formula. Let us see that how many points this formula will generate. Or is there any difference between this? So here, when I put n equal to 0, I get 0. So I stand here. But when I put n equal to 1, I get 180. You see, I immediately jump to this point. And if I increase it one more, it is 2 times 180. I suddenly jump here. And if I do it in the opposite direction, I will end up with the same points. So you see, it is extremely important to understand that from trigonometry point of view, this algebraic formula and that algebraic formula, even though from algebra point of view, they are different, you can see the difference, but they are equivalent for us, meaning that they generate exactly the same group of points on the unit circle. So this is extremely important that you need to understand that. But let us see that algebraically. Algebraically is also very important to see. Algebraically is also very important to see. So you would say that, what is the difference? Here, when I put n equal to 0, this formula generates 180. When I put n equal to 1, this formula generates 360. And I don't know, if I put n equal to 2, the formula generates, I don't know, 540 degrees. Okay, and this will continue. But this formula is a little bit lagging behind, yes? If I put 0, it generates 0. But when I put n equal to 1, it generates 180, which is in my list. When I put n equal to 2, it generates 360 degrees, which is in my list. If I put n equal to 3, it has a 1 unit delay, you know. When I put 3, it generates 540 degrees. So these angles are exactly those angles. Is 0, how can I, do you think that I can get 0 in this list as well? Because if not, it means that these formulas are not equivalent. One of them is generating 0. Do you think that 0 can be generated using this formula? The answer is yes. It is clear that you can choose n equal to -1. If I choose n equal to -1, this formula generates 0. So you see that if you are patient, of course, practically not possible, but you can imagine it. If I list all the angles generated by this formula and list all the angles generated by this formula, finally the lists are identical. But the point is that when 180 is generated here, when n is equal to 1, when 180 is generated here, when n is equal to 0. So this formula is a little bit lagging behind. But at the end, if you are patient and do it if you finalize it, the angles that you generate are the same. If you want to understand it more better, here you can factor 180 degrees out. Then this becomes 1 plus n times 180 degrees. If n is an integer, n plus 1 is an integer, the other way around. So it means that I can give it a new name. I can call it n, and then I can write it as n times 180 degrees, yes? And then I can write n belongs to z. So you see that this one is exactly this one. This tells you an integer multiple of 180. This is also telling you an integer multiple of 180. Might be you don't like the letter n, you want to choose letter m. That is also possible. So this formula is also completely equivalent to formula, this one. I am just changing the letter, yes? So this is extremely important, that don't judge the formulas in trigonometry based on their algebraic appearance. You need to see that if they are generating the same class of points. If yes, they are equivalent. So it doesn't matter which one I use. But which one you prefer to use? This one or that one? Of course, the second one. The second one is more elaborate and more compact. So let us use this one. So this I want you to understand. In the exam, if the answer is supposed to be here and you end up here, I will accept it for you. But I just want to understand that it's a better understanding if you are able yourself to summarize this formula into that formula. It's extremely important for the students who are interested in more understanding things better. So if I myself end up with this answer, I think a little bit, can I make this formula shorter? And if yes, I prefer to write it in a shorter way. Okay? So, oops, I shouldn't clean this, sorry. Or might be we don't need it. Okay, so let me give you another example to understand this thing. Let me make it a little bit harder. For example, in the future, you solve an equation, you get two answers. You get two possible answers. You would say that one answer that I get is this. Let me write it in this way. So, for example, you get two answers. What should I write? Let me think a little bit. You get 180 degrees plus n times 360 degrees. And you see that, for example, you get these answers, and then you get these answers as well. So, for example, assume that you solve something and the answer to the final problem are two things, not one possible. You say that this is possible, this is possible. So you expect to go, when you go to the faucet, you expect to see two solutions, this one and that one. But you surprisingly see that the answer in the book is this one. Of course, every time I am assuming that n belongs to c. So you see, it's like quadratic equation, for example. Do you remember when you solve quadratic equation, most of the time you get two answers. Now, this can also sometimes happen in trigonometric equations. You solve a trigonometric equation, instead of getting one possible answer, you get two possible answers. And you say that, okay, I am happy, I got two answers. And when you go to the faucet, you see that faucet has written one answer in this form. Which one is correct, do you think now?
The upper one with the box, it describes 2 points, but the lower one with the box, it includes both.
So, no, both of them describe infinitely many angles, but you said that this describes 2 points, this describes 1 point, yes? If that is the case, then it means that one of you are wrong, yes? Either the faucet should be wrong or what you have done is wrong. So do you see what I'm saying? You solve the problem, you get two groups. Pardon, may you repeat?
The lower one includes both of them. That's the
so you mean that they are equivalent, yes?
Yes.
Okay, so it means that yes, you are right. You solve this one. If you are careless, you leave it like this, and that is okay. I don't have any problem with that. But I want you to learn, if you are interested, which one do you prefer? If this one single one works for both of them, I myself prefer to write it in compact form, yes? But you need to understand, are they equivalent or not? How should I understand? I will just draw a rough picture for myself. You don't need to be precise at all. So you see, I'm just drawing a very messy picture. But let me see that what are the endpoints corresponding to this. You see, this is a full circle, and this is 180. So where is it? It is here. For example, if I put 0, it becomes 180. It is here. If I put n equal to 1, again, I end up here. So this formula only gives you 1 point. You start from 180, you go one full round in either direction. So it is clear that you end up exactly the same point. So this formula in its own is capable of generating one single point. And this formula, what about this formula? If I give n equal to 0, I end up here. If I give n equal to 1, it becomes 360. I also end up here. So this formula is only capable of generating 1 point. So, but I need 2 points. probably the answer to that problem is 2 points. So this is why in this form I write it with two formulas. But it is immediately easy to see I can combine these two formulas into one single form. I ask myself, can I write a formula that generates exactly these 2 points simultaneously? Sometimes it is possible. In this case, it is possible. I hope that you agree with me that this formula generates both of them. Because if I put n equal to 0, I get 0. If I put n equal to 1, I jump to 180. If I put 2, I jump to 360. So you see, this formula generates both of them simultaneously. Okay, it's extremely important to understand that. So this, if I end up with these two solutions, I myself prefer to write it in a compact form. But of course, this n is different from these two n's. But that's not important. I just want to think about a formula that generates my points. The n that the book uses here, the faucet uses, is not the same n that I use here and there. But there is no one single number for n. There is an infinitely long list for n. So it means that if you use all the n's, what you will generate at the end is the union of the angles generated from here and the angle generated from here. This formula in its own is capable of generating both groups. Okay? So these are extremely important things. They haven't discussed this in so many details in the book, but it is something, it's really, really important. So I just elaborate this lesson, a very long one, because if you understand these things, so then the later things would be easier for us. Okay, good. Any questions here? I just want to teach more or less 10 minutes and then we are done. Okay, now what we want to talk, here I haven't talked about trigonometry that much. What we learned is that in trigonometry, angles can be bigger than 360 degrees. They can even be negative. We gave meaning to it by comparing every angle in the unit circle. Okay? We gave an origin, we gave a direction for the unit circle. And from now on, everything we want to work in trigonometry is in the unit circle. Okay? So if you understand the unit circle, more or less, I would say 50% of your trigonometry is actually overdone. Okay, now we know that if you punch this number in your calculator, you get a number. But if you remember, we talked about trigonometry in the right angle triangle. So this should be meaningless if the lesson was the previous lesson. I cannot have a right angle triangle whose one of the angles is 300 degrees. But if you put this in your calculator, you get a number at the end. So it means that calculator somehow knows about the meaning of this, even though this is meaningless in the previous setup in the right angle triangle. So now I want to define sine, cosine, and tangent of the trigonometric angles, which of course includes right angle triangles as well. So what we say is this. I give you a trigonometric angle. So for example, say theta, a trigonometric angle. I want to say what is the meaning of sine theta. I want to say you what is the meaning of cosine theta. And finally, I want to tell you what is the meaning of tangent theta. So the definition is a little bit different. Actually, totally different. But for acute angles, they become equivalent. So what I do, if I want to understand what is the meaning of sine theta, what I do, I will take this angle and find its end point. You see, the final point. This is why the final point I discussed so much. If I give you this angle, what you do, you start from here, and you start rotating about A through an angle theta. If theta is positive, you start rotating in positive direction. If you have a negative angle, you rotate in the opposite direction. But what is clear, you will end up at one single point on the unit circle. Okay? For example, for definiteness of discussion, so let me say something like this. Assume that you put your leg here. I don't know if this is so big, you start rotating over and over again. If this is a small, you just rotate a little bit. But anyway, assume that you end up here. Okay? Assume that, let me write it in this way. Assume that you rotate and you end up here. Okay? Then this point, don't look, now forget this unit circle. You are left with a coordinate system and you are left with one single point. That point has two coordinates, x and y. Okay? And then it is simple. We say that sine is y. We say cosine is x. We say tangent is y divided by x. As simple as that. You see, let me just repeat. I give you a trigonometric angle, positive, negative, greater than 360 degrees, smaller than 360 degrees, doesn't matter. If you need to locate the final point of this angle on the unit circle. It is clear you end up somewhere on this unit circle. Then just eliminate this unit circle in your head. You are left with a coordinate system and a point. Every point in the coordinate system has two coordinates. One of them is x, one of them is y. We say that y is defined to be the sine of the angle, and x is defined to be the cosine of the angle. And if I divide y by x, it is defined to be the tangent of the angle. Is it clear? It's a very simple setup. For example, I can probably ask you for a nicer angle. So, for example, can you tell me what is sine of 0 degrees? What is cosine of 0 degrees? And what is tangent of 0 degrees? You see, this was not in our list. Do you remember our famous angles in the previous setup were just 30, 45, and 60, because 0 is not an acute angle. But now in this setup, we can calculate. So what should I do? My angle is 0 degrees. So what I have to do, I start from here and I start rotating through this angle, but this angle is 0, so it means that I do not move at all. So what is the final point corresponding to 0 is A itself. Yes? Now, can you read the coordinates of this point for me? Do you remember? The circle is the unit circle. Okay? So can you read the coordinates? The x coordinate, what is the x coordinate? Everyone, what is the x coordinate of A? Yes?
1.
It is 1. What is the y coordinate? It is 0. As simple as that. Sine is the y coordinate. It's 0. Cosine is the x coordinate. It is 1. Tangent is the y coordinate divided by the x coordinate. So it becomes 0. As simple as that. Let us test another idea. Let me ask you, do you remember in my list 90 was absent? Sine of 90, cosine of 90, tangent of 90. So it means that I need to find the final point corresponding to 90 degrees. I start always from here. This time I have to rotate 90 degrees. I rotate 90 degrees, I end up here. And then what my duty is to read the coordinates. This time, the x coordinate is 0 because I am on the y-axis. And what is the y coordinate? Because the radius of the circle is supposed to be 1 always. The y coordinate is 1. Now, if I ask you to write something in front of sine, you need just to remember this in your memory. Sine is the y coordinate by definition. Cosine is the x coordinate. Tangent is the y coordinate divided by the x coordinate. So sine of 90 degrees is the y coordinate. It is simply 1. If you don't believe, you check your calculator with your calculator. Cosine of 90 is the x coordinate, is 0. And what is tangent? Tangent is the y coordinate divided by the x coordinate. Everyone knows, undefined. So tangent of 90 degrees is not a number. You can check with your calculator. You probably get an error or something. Okay? So, let me ask you another one. What is sine of 360 degrees, cosine of 360 degrees? And I will make it formal next time. I will write it correctly. I will write it very organized way next time. But I just want you to understand this. So what is tangent of 360 degrees? Of course, you can also go do the same thing, but immediately you know that 0 and 360 degrees, even though they are quite different angles, but the whole point is that the final points are exactly the same point. And what matters for sine, cosine, and tangent are x and y coordinates of the final point. So if the final point is the same, it means the x coordinates are the same, the y coordinates are also the same. So you don't need to do it again. You immediately say that what happens for sine of 0 degrees, I get 0, I will get the same number for 360 degrees, even though they are quite different angles, you know. And if I ask you what is the cosine of 360 degrees, because the end point of 360 and the end point of 0 are the same point, so it means that this becomes exactly equal to 1, and this also becomes exactly equal to 0. Yes? Okay. So this part I will repeat again. So next time I will start reviewing this little part again. But I expect you to understand what I said here, so I will never repeat this one. We don't have time to repeat this over and over again. But this I will repeat for the next time, which is very, very important. So if you understand this, then you can discover a lot of formulas, because there are many formulas going on in trigonometry. Of course, if you work very hard, automatically you will start memorizing them. But if you don't work very hard, still you understand what is done in the unit circle. You can rediscover all the formulas that you need on the go, yes? So that is my advice for you. Okay, try to be with me with the next lesson. And if you lose the next lesson, more or less you will lose substantial part of trigonometric lesson, including the one that is coming for the next lesson in Math 4. Okay, so thank you for being with me here. Yes, and I told you that if you think that the video is helpful, please like it. If it is not, please dislike it. No neutral person, thank you. I will end this stream, and then I will be 1 minute in Zoom if you have any questions. Thank you.